Okay, so we've seen that if you know how many moles you have, you know the mole count. You multiply by the how many items you have in one count. This is going to be Avogadro's number, 6.02 times 10 to the 23rd. Then you get the individual count. Okay, so number of moles multiplied by Avogadro's number would give you the actual count, big N. So let's just try to use this formula to answer this question. How many moles of magnesium atoms are in a sample containing 3.00 times 10 to the 23rd magnesium atoms? So what do we know here? Little n, big N, or big N sub A? What are we looking for? How many moles, right? So we're looking for a big little n. So how do I solve for little n here? Divide both sides by Avogadro's number. So I'm going to divide both sides by n sub A. Okay, so in other words, if I know my individual count, if I want to go in reverse, I want to know the mole count, I just divide by Avogadro's number. Okay, so I can say then my number of moles here is equal to the number, which is 3.00, the actual number, 3.00 times 10 to the 23rd, the actual individual count, divided by the mole count. So this is atoms, okay, and to be more specific, you say it's magnesium atoms, divided by Avogadro's number. It would be 6.02 times 10 to the 23rd magnesium atoms per mole, right? So atoms cancel out. That gives you the answer in moles. Notice that in your denominator, okay, mole is in the denominator of a fraction in the denominator. So when you're dividing by a fraction, you flip it. So if you, so your final unit here will be in moles. Okay, so let's calculate that. 3 times 10 to the 23rd divided by 6.02 times 10 to the 23rd equals 0.498. And the unit is moles. Okay? If you prefer doing this using dimensional analysis, here's a way of looking at this. You can say 3.00 times 10 to the 23rd atoms. Anytime you're dealing with proportional quantities, you can use dimensional analysis. You can say times, okay, I want to cancel number of atoms, and I want to put moles on top, right? So I can say that 1 mole up here corresponds to 6.02 times 10 to the 23rd atoms. So this is your conversion factor right here. So this is like unit conversion in a way. So atoms cancel out. So essentially, what you end up getting is the same answer. Of course, you have to. Okay.